Hi, welcome back. So here I have uh, loaded the same data, but without column as uh, column header as true. So we didn't load the column header properly. So that is why you are getting the data like this. So instead of that, you can have a command option header equal to true will give that particular parameter argument here. So when you give this option header true means the same header will be added as a header to this particular data frame created. So ultimately when you read the data here, it's still in progress. Let it complete and then after it completed we can execute this statement to see the data. So now it properly load the data. So this is how it is so simple to load the data from S3 location to your Spark data frame. So you need to understand that this is actually a location in cloud in some different system. You are executing this program from your EMR machine. That is in a different system in the cloud. You can simply read this data directly from your S3 location by giving the path of that particular file and then read the data as a CSV and CSV format and reading it to the data frame. So once you read this data frame, you can treat this data frame as like any other data frame we have tried out some example in our local machine, right? The same way we can use this data frame and we can run all the programs. We can find out, we can use that, execute that program to find the uh, uh, problem with the football players or the other problems we have executed with the data frame in our local machine. Same thing we can try it out and it will be more fast also. So more faster means you can see this uh, resource manager. So resource manager is we this many applications we have executed. So this is a yarn UI. So it will show the active nodes available here and what is the total memory available. Memory used only 896 MB used. Total memory is 12 GB. We have mainly three nodes, one master and two cores, two core nodes. So this is the total cores available. Then all the configuration information will be available in CC UI. So it will show the load actually, how much memory currently using, how many applications running or completed, any application. So if you click on the running, it will show the running application. So if you look at this application, this is a Livy session. That is something available as default. So you don't need to worry about that. So how many finished? So finished as of now, I don't see anything. We didn't run any Spark as a program. So this is something which is running here. And if you look at this, right, if you go to right side, it will show whether this is Spark or Hive application what are we running. If anything is failed also, it will show here below. Uh, these are the two active nodes which is available. So if you look at this, these are the two core nodes where actually it is running the data and execution and everything happening. So currently in this particular node, second node, right, nothing is happening because we don't use any execution programs to consume that particular data. Only one core is currently is being used in 96 MB and this much memory is available. Those many cores are actually getting wasted now because we are not doing any execution here. That is why it is sitting idle. But both the cores are running now. So it's up to you to decide how much memory and how many nodes you need for your execute program when you start a project from your side. So you can understand all those things when you look at the Yarn resource UI. How many cores are there? How many cores are actually utilized or unutilized, whether it is required or not. All these things you can decide by looking at the CY. That is one thing. Then this is the hue, right? How to create a Spark. I'm sorry, how to create a Hive database and tables from the S3 location or any local location also you can create. You can connect the Spark SQL also here. So Spark SQL is something like you can write a simple query from the Spark, Hive table, and uh, in a query format you can write the Spark code. As a simple SQL. That is the only thing used about the Spark SQL. These things were recently added in the latest version of EMR. It was not available initially. And that is S3. You can browse here tables. You can browse what all tables are available in your Hive environment. And then if you go to Jupyter Notebook, this is how you are using Jupyter Notebook like any other application. I'm not sure. I'm unfortunately not able to see the Spark UI here. We'll see how we can enable it. So apart from this, if we go through the EMR console, there is something called Zeppelin. Zeppelin is actually similar to Jupyter Notebook. We can create an interactive notebook and we can write Spark or Python code, and then you can view the result on the Zeppelin notebook itself, and it also have a visualized. You can have a graphical visualization for the data, whatever you are going to create. So for example, I'm creating a notebook here, new notebook, which is using Spark. So we have a different interpreter here, Spark, Angular, SH, VB, Python, and everything. So for the time being, I just create a Spark about you can execute by you have an option to export the note. You can clone the note, then show or hide the code, show or hide the output. Once we have the code and output here, you can decide which one to show, which one to decide. Then the same command, I'm just going to write it here. I think this is Scala Scala compiler. You see, that's why it's showing. For now, we'll just keep this. This is actually not a PySpark environment. It is a Scala Spark environment. That is why it didn't work. So I'm just reading the same data from the S3 location to a data frame in Scala Spark. So data frame is loaded, and then we have option to change df dot show to display the data which is created. So you can see the data here. So that is done. So we have some many options here. We can insert new cell, move down, move up, remove or delete the code or data, whatever is displaying here. So all these options are available. And apart from this, you have option to create the jobs also here. You can run it. You can, for example, I'm just going to this one of the tutorial which is available in Zapier. So this and programs and all you can try it. Okay. So this is there are some default location in S3. They are actually reading the data. This is actually they're reading some data files from the S3 and they are creating some data frame here. So ultimately, there is some option to for you to view the data in a graphical format. So if you type this percentage SQL and then you can write your, I will go back and will select the previous note I have created. So untitled note here I have created, right? So here we will create a. So it is running and we got the output. So the same data I stored as a temporary table in the Spark SQL, and then I can run the simple query select star from the table name. So you'll get the data. The same data you can. So bar chart is you can use when you can write this data in a some. If you, for example, if you are going to group the data, okay. Let me take an example. So we'll go to this and see some different data. So where we can group actually. So we'll go to this file folder and source. Just checking some data which has okay, we'll take an or CSV. So instead of loading this chain uh, employee.csv, I'm running this. And I'm going to create a temporary table as employee here. Now, if you read this data from employee, let's say 20 records. So here I will write a query, select EMPL type code, comma, count star from employee, group by employee type code. So in case if there are multiple employee type codes, it will group the data based on employee type code and it will show the count. So hope you understood what is the logic I am writing. So, but unfortunately there is only one employee type code, so you can do any aggregation here. So let's have a look at it, some different data, different columns where we can do the grouping. Employee positions. I will take a distinctive view and we'll see how different type of employee positions are available. So we have three different types of positions are available. So I will write a query to find the employee count based on the employee position. So it will show the data based on grouping group by employee position and then executing this query. So this is how we are getting the output. Count 5 to 1 like that. So if you give the bar chart, it will show. I'm not sure why it is not showing this output. Actually, it's supposed to show the graph here. Okay, so it's showing here. But, other graphs are not showing. So we'll see that we'll look at the other example and see how the data is coming. So let me execute this particular code. And they are creating a table, first of all, called bank. And on this particular data, they are writing some query. Query is basically on the group by age level grouping they are doing and then find the count. So when you do this execution, you'll get the output either as a table like this or as a graph in a bar chart format. The same thing in a pie chart format. So what level age group is having higher contribution, you can find it out. If you look at 27, 28 having more, and 29 having the more, 26. So other age groups having different very less contribution. So from the pie chart, you can easily understand this. So this is a different level of graph, bar chart in the bar diagram. So in each age group, will show what is the total count. The same thing in area chart also you can see using line chart or scatter plot. So the different ways you can do the visualization in this Jupyter notebook for the same data frame that is loaded here. And we have writing some different queries. Here I am writing from the same table for age greater than 30, and then so here we are as an argument, right? So we can either pass an argument at 35, or by default it will take 30. So if below 35, what is the age group having maximum count? That is what it shows. Then other things, actually here I'm doing select star from rank, then grouping based on the age. So where condition is actually marital status equal to single is the default, or you can pass this value as a,
മറ്റേ എന്താ പറയാ
yeah. എന്താണ് question പറയൂ. Hello. Hello. Any questions? Okay. So age level, I'm doing the grouping and order by. So when you give this where clause, and we can add as an argument. This is some kind of properties available in this Zeppelin notebook. So we can add an option, single, divorce, married, all these options I can give as a marital status, and by default I'm doing single. So it will give a drop down or a text box according to the options we are providing. So from that options you can select whatever data, okay, whatever marital status, either level of customization you have to get the data, you can select it, and then accordingly a result the query will be fetching, then you will get the data. So this is very big pie chart and different lots of age groups. You have an option of downloading all this data as CSV also into a local machine. So this is a small example of how to use a Jupyter notebook. But ultimately, the whatever programs we have already seen, right? So in case if you can connect to this and create an EMR server and do some hands-on, I will request you to, I will send the same programs to try it in a different way. So I will give some use case how we can try it out in case if you are going to start an EMR cluster. So I will send a mail today. We will have some use cases like whatever the data we have already solved, right? That you can use as a programs within EMR. So we can move the data to S3 and create a Hive table. You can connect to Jupyter Notebook and write a smart program to read those data, and then join with another data frame, and then do the grouping and find the you can resolve some questions what I am mentioning in that particular program. The same example we have tried with our local machine, right? So we can move those data to the EMR and then start working on that. So you can upload all this data and all the data set to S3, and from there you can write your smart program to read the data from there and try to solve the example. So then you will get more hands-on experience working with a remote environment, cloud environment, working in a remote machine rather than just everything working on your local machine. So here the CMR cluster currently it is running. If you know, you know that, right? It is a two node, two core nodes and one single master node is running. So if you go to this EC2 area, you can see all these nodes are running. So running instance will be 3 because we have one master node and two core nodes. So there are 3 machines are actually 3 nodes are running at the same time. So if you click on this particular thing, you will get the public IP host name. If you click on that other one, there also you will get this is a master node M4X. These are the core nodes. So you can, if you want, you can log into all these machines. You can using SSH. You have the SSH connectivity, and you can see whether all the services are available and there or not. Definitely it will be available. So similarly, you can create a free clusters also. You can create like this. You can create a free three clusters, and then you can install manually all this Hadoop, Hive, Spark, and everything in each machine, and then you can configure one node as a Hadoop master node, and other two nodes are Hadoop slave nodes. That also is possible. I will send out a note how to spin up a multi-node cluster in EC2. So EC2 multi-node cluster means you don't need to pay anything. It is free of cost. Uh, but you need to ensure that you are selecting the free tier eligible node. I mean free tier eligible machine from the EC2 when you launch the instance. So you can replay the node session I have taken how to spin up EC2. So I'll also send a note, a document which shows how to spin up a multi-node. I mean, for example, let's say three machines, three EC2 free cluster, free machines. So one by one, you will be spinning up three EC2 machines, and then one node you will consider it as a master, and two nodes you will consider as a slave nodes. And you will configure the Hadoop in master as a master node, and other nodes will configure the Hadoop as a slave node. And then you will start Hadoop, then all these things will work as a Hadoop slave and master nodes. So you can write some programs, you can execute and see how the things are working. And you can, on the top of that, you can install Spark also. But we need to make sure that when you install Spark on top of the Hadoop on the free tier cluster, there can be a chance of getting machine hang, or Spark session might crash down in between. There is a probability like that because it is just a 1 GB memory you have using, right? But won't be if you are writing a small programs, it won't cause any issues. So this is the same EMR machines. It will show in this console also, because it ultimately whatever server we are spinning in the EMR also is a EC2 machine only. That is why it's showing there. But this is a enterprise version of the big data environment from the AWS side. So it has all the capacities and capabilities to process and everything. All the applications will be there. You can install more application like it Scope, Pick, and that is I didn't select that actually. You can select that options and then spin up. Then it will you will have all the available services. So this is a Spark history server. You can launch from here. I think the pop-up is blocked. That's why it's not showing here. So here, Spark history server will show some anything which is not completed or so whatever completed stages will show here. Like a normal Spark server UI, but it's a history server. So here also it will show whatever executors are available. So if you go to environment, it will show the environment. So Java version, Scala version, Spark properties. And Spark history server yarn address. So all these properties will be available in the environment section. So you can have a look at this. Is very long. So many properties are set here. You look at the storage. I'm showing anything. Stages, jobs, and everything will show here. So about Zeppelin notebook is something like the same way how we are working with the Jupyter notebook. So here there is some option for visualization, visualizing the data like this. Apart from the writing the data on the data frame and saving the data, instead of that, we can do the visualization also in this something. So the advantage is actually you don't need to configure anything to read the data from S3 or read the data from Hive. You can directly read using Spark SQL from Hive table, whatever Hive created in my environment, and you can work with this. So you have so many flexibilities and facility features are available when you have a EMR machine, like a Jupyter Notebook, or whether it is a Zeppelin or Q or other services. So you have a lot of facilities and features available, and you can try a lot of things hands-on and everything. So when you start looking at this EMR services, so that is one of the very big advantage when as a student beginner to the big data and studying this all these things. So you have a lot of exposure to the real-time uh, tools and properties, tools and environment, what yeah, uh, really using in the tradition in the real-time world. I mean, real-time world ഉദ്ദേശിച്ചത് normally when you work with a particular project in any particular company as a data analyst or data engineer, you need to work on a lot of tools, not, not just simply programming in your local machine and then compiling it and executing. Instead of that, you need to have some exposure to all these tools and understanding apart from just the programs. So that one of the big key things about the big data world, or big data development, or big data support, whatever you are working on, you need to understand a lot of things, services, components, systems, which is continuously changing, whether it is in a on-premise machine അല്ലെങ്കിൽ ഒരു cloud machine ലായാലും continuously a lot of evolution and changes വന്നുകൊണ്ടിരിക്കുന്ന ഒരു ഫീൽഡാണ്. So you need to have exposure to all these tools and how these things are working, how big data systems are configured in backend, എത്ര machines available ആണ്, അതിൽ മെമ്മറി എത്ര യൂസ്ഡ് ആണ്, എത്ര ഫ്രീ ഉണ്ട്, അതുപോലെ അതിന്റെ പെർഫോമൻസ് ആൻഡ് execution performance and optimization, അതൊക്കെ എങ്ങനെയാണ്. സോ വി നീഡ് ടു അണ്ടർസ്റ്റാൻഡ് അതിലേക്ക് കൂടുതൽ വർക്ക് ചെയ്യുന്നതിന് മുമ്പായിട്ട് തന്നെ യു ഹാവ് ടു അണ്ടർസ്റ്റാൻഡ് why if you get into a project, there'll be a lot of asks, requirements, something like optimizing the existing properties, performance and everything for a job is getting executed, or you may need to automate a lot of things. So currently in most of the organization, they are trying to do a lot of automations as part of the big data programs and executions. So you need to understand how to automate, how to schedule something, just some jobs and all. So this is a good opportunity to, if you have some exposure to this cloud services, or even in Databricks also there are some free services are providing. So you just make use of that. That's one of the things I just want to tell you. And today by in evening I will send you some scenario questions, like whatever problems we have solved, we can try it in EMR whenever if you are going to start. So I'll just send it to you. And apart from that, a few more use cases I will send it to you, which we have not tried. So that either you can try it in your local, or if you are starting EMR cluster, you can try it there also. And in the next session, I will start with the Spark streaming. Okay. First of all, when you start with Spark streaming, I will start with this structure streaming in the Spark, and then after structure streaming, I will move to Spark streaming also. So before getting started with Spark streaming, I will show you some example how to create a job, how to create a scheduler in this, using how can we create a jobs and schedule it. I will show some example how to create it, and then after that we will move to the Spark Stream. Or in between Spark Stream itself, I might show this, so you will be able to understand how to create a job and schedule it, how to create a workflow. So today, any questions? I will stop. If you don't have any questions, I will stop within 5 minutes. So in case if you don't, if you have any questions, you can just raise it now. I'm just terminating this particular environment for now. So I will tell you one more thing. In case if you terminate this cluster, and tomorrow when you come up, you will have a history here. Okay. And if you click on this, you have some option to clone this. So you don't need to do anything tomorrow. You can just simply click on clone and then create a cluster. The same cluster will be recreated tomorrow. Understood. But once you terminate, whatever the application or data stored in EMR will be gone. So only thing is same configured cluster, you can recreate it by just using clone. So you don't need to do set up any configuration again. So this is just some visual representation of how a Spark SQL and how high metadata and everything is connected together in the EMR. So suppose this is a Spark AWS EMR cluster. So whatever we have currently worked on. So suppose we have multiple EMR cluster, right? So we can create a common high meta store repository. So we can, so that particular Spark environment can directly read the data. We can share the data which is in the Hive in a separate Hadoop cluster. So this is a property available as a Spark. For Spark, using a Spark engine, we can have this property. So we're just showing how to running a Spark SQL application with a remote Hive cluster, apart from the local machine. So that is just an example. You can just have a look at this. Nothing much, nothing important. I just showed you this. So for now, it is getting terminated. All the machines will be terminated once you click on terminate. So they are introducing some latest feature in EMR 5.2.1.28 version onwards. They are comparing the performance in the previous version 5.16 to the 5.28. They have saving this much time. I mean, for 1.89 minutes reduced to 0.77 minutes because of this new feature available in the EMR execution for Apache Spark. So the EMR is a continuously changing and evolving. A lot of things are happening in EMR and also in the Spark and Apache Spark world. So recently there is a release of not recently, almost couple of 6 months back, I think. Spark 3.0 version is already released. So slowly, most of the people and companies might move to Spark 3.0. So we need to start looking at the advanced features available in Spark 3.0 also. So we can take some session also on top of what are the additional features are added in as part of the Spark 3.0. So this is from my side for today. If you have any question, you can shoot it, or otherwise you can close the session for today, and we'll meet on Monday.
Okay.
Okay. So in case if you have any doubts and everything, you just don't hesitate. You can just raise your questions, and then either email or WhatsApp. I will try to reply as soon as possible. Okay.
സർ ഈ ഇമെയിൽ അയക്കുന്നുണ്ടായിരുന്നോ? എനിക്ക് കിട്ടുന്നില്ല ഇമെയിലുകളൊന്നും.
ഇമെയിൽ ഇപ്പോൾ 2 ദിവസമായിട്ട് ഞാൻ അയച്ചിട്ടില്ല. ഐ വിൽ സെൻഡ് ഇറ്റ് ടുഡേ. ഇതുവരെ കവർ ചെയ്തത് അയക്കാത്ത ഏതെല്ലാം സെഷൻസ് ഒക്കെ ഐ വിൽ കൺസോൾട്ടേറ്റ് ആൻഡ് ഐ വിൽ സെൻഡ് ഇറ്റ് ടുഡേ.
ശരി ശരി, ഓക്കെ
ഓക്കെ.
ഓക്കെ.
പേര് എന്താ?
പ്രേംജിത്ത്. പ്രേംജിത്ത്.
പ്രേംജിത്ത് അല്ലേ? ഞാൻ ആഡ് ചെയ്തിട്ടുണ്ട്. പേരെന്തായാലും അതിലുണ്ട്.
ഓക്കെ, ശരി, താങ്ക്സ്.
Okay. Okay. Thank you. So anyway, I'm stopping today. We'll see you in the next class. Thank you.